Good morning, good evening, good afternoon. Today we will be continuing the second part of standard model. Let's start with about quarks. There is up quark, down quark, charm quark, strange quark, top quark, bottom quark. And the up quark and down quark are both generation 1. Charm and strange quark are both generation 2. And top and bottom are generation 3. In this, the first generation is the lightest and the third generation is the heaviest, and this third generation is the least stable and the first generation is the most stable among them. And then these are our normal quarks, and then we have anti-quarks. In this, there's anti-up quark, anti-down quark, anti-charm quark, anti-strange quark, anti-top quark, anti-bottom quark. We had seen that quarks have electrical charge, that is positive, negative, and those all. Like up quark has positive 2/3 of electron and down quark negative 1/3. So apart from electrical charge, there is another charge, that is color charge. We have made it for our convenience. The quarks are not actually colored. Let's take one possible arrangement of the quarks of the proton. If we see here, these color charges are divided into three colors: blue, red, and green. And they are divided based on how they interact with the gluons. Don't think that this is the only arrangement of the colors of proton, because the quarks continuously exchange the gluons. We cannot say that a specific arrangement of these colors is the only arrangement which we see the particle in, because they continuously change color arrangement. If we add blue, red, and green, what would we get? We get white. How? You see, there is a bit of white in this. That's why we say that all the hadrons which have three quarks should be color neutral. If we add all the colors, the resulting color should be white. Mesons, the colors of quark and anti-quark, make up white. In the previous video, when we were classifying the particles, we came across hadrons, the two types of hadrons, baryons and mesons. Baryons can be proton and neutron, and those particles which have three quarks. But what are mesons? Mesons are those particles which have one quark and one anti-quark. Some examples of these mesons. First, let's see kaons. K plus the quark combination up quark, anti-strange quark. So its structure will be kind of like this. Take the complete opposite of this strange quark and anti-up quark. A general form to write mesons, that we should write them like this. First one should be quark and second one should be the anti-quark. 0, K neutral. Then its composition is down quark and anti-strange quark. You see, only the up quark has been changed by a down quark. K0 bar, and the complete opposite of this is strange and anti-down quark. All the kaons have spin is equal to 0. Moving on, we have pions. Again, there are different types of pions. Positive pions have composition as up quark and anti-down quark, and the opposite of this and the anti-pions, down quark and anti-up quark. Then there is pi 0, pi neutral. If we take pi 0, it is a mixture of this and this. You might wonder, how can this particle have this or this? And mind you, it's not or. It's not at all or. Both the combination of quarks occur at the same time. They are simultaneous. It's a superposition of both of these combinations, and it won't matter if there is the negative, because same if we interchange the letters can be represented by they are in a superposition. We have to use this representation. The spin of pions is 0, just like kaons. Next up, we have rho mesons. The rho mesons, our composition is exactly the same as that of pions. You see, it's exactly the same as that of pions. It's also the same with this and this. It's also the same as of pions. Why are these two different particles even when their superposition is the same? That's because the rho mesons are heavier than pions, and another difference is that pions had a spin 0 but rho mesons has spin 1. Now we have eta c. Its composition is cc, so it wouldn't really matter if I just put anti eta c, because it would be practically the same. Eta c have spin 0 and they are neutral. That was it for today's video. Goodbye.